So this is section 7.1, the Pythagorean Theorem. Now lots of you guys have probably worked with the Pythagorean Theorem at least a little bit, but we're going to start there, and then the rest of this chapter we're going to be talking about right triangles. So 7.1 in the Pythagorean Theorem, we need a specific type of triangle for the Pythagorean Theorem. We need a right triangle, and as you remember from Geometry A right triangle is a triangle that has one right angle. Okay, so that would be a right triangle. Right triangles have very specific parts. The side that is opposite, okay, so the side opposite, that's this side right here of the right angle. The side opposite the right angle is called the hypotenuse. So let's label that. That is the hypotenuse. Hypotenuse. Okay, and then a right triangle also has two legs, so it's three sides. We've got one side is the hypotenuse, the other two sides are the legs. So this side here, and this side here. These are legs. And typically we're going to label these legs A and B. So we'll call this first leg here, we'll call this A, and we'll call this leg B, and then we'll call the hypotenuse C. It's almost always how we'll do it. And the Pythagorean theorem, as you probably remember, is a squared plus b squared equals c squared. And we can use this to find missing side lengths. Okay, so if we suppose we had two legs, we knew two legs, and we want to find the hypotenuse, we could plug that into the formula, and we could find the missing part, whichever part that is. As long as we've got two of the legs, we can find the third leg. So you need to remember a couple things about the Pythagorean theorem. You need a right triangle, first of all, and you need to remember that generally, in fact, all the time in this class, A and B are going to be the legs of the triangle, which, remember, are the sides that are adjacent to that right angle. And the hypotenuse, side opposite the right angle, is going to be C, almost, well, in this class, always. So let's try some examples using the Pythagorean theorem. So let's move over here to, whoa, okay, let's move over here to this example. Woo! This first one here, this 18 inches, 30 inches, and then we want to find that missing leg, okay? So that's our instructions, find the missing side in the triangle. So let's start. Remember, we know the Pythagorean theorem is a squared plus b squared equals c squared. Right, and now the first thing I'm going to do is label my sides. Oops, real quick. This is our right angle. Sorry. That's our right angle. So let's label our sides first. I'm going to call this a squared. I'm sorry, A. Call this side B. And my hypotenuse is always C. Okay, so C equals 30. Let's plug everything in now to find B. That's the missing side that we're looking for. So A is 18, so I'm going to have 18 squared plus B squared. Well, that's what I'm looking for, so we'll leave that as B squared. Equals c squared. Oops, I'm sorry. Shouldn't be c squared. It should be, we know c. So c should be, 30 squared. In fact, let's see if we can't make that look a little bit nicer. I'll call that 30 squared. Okay? And now we just need to solve for b. So, a couple ways that we can do this. I'm probably just going to minus 18 squared right now. Leave it in kind of that squared form, and then we'll have b squared equals 30 squared minus 18 squared, and you can plug that into your calculator, and you should get that comes out to be 576. Okay, so b squared equals 576. To solve for b now, we want to finish this problem up. To solve for b, we're going to take the square root of both sides, so we'll square root this side, square root this side. And technically this would leave us with plus or minus a number, but we know that a length always has to be positive. So we're left with b equals the square root of 576. And once again, you plug that in your calculator and you should get that b is 24. And inches is our units, 24 inches. Okay, so that's the first example. If you need to pause and kind of finish writing the information down, then go ahead and do that. Otherwise, let's move on to example number 2 here. So let's see if we can't zoom in, and then let's going to divide this off and maybe try a different color here and maybe write a little bit smaller so we can fit more on the page. Alright, so now this time I want to find the missing side, and this time the missing side is the hypotenuse. C is what I want to find. And once again, this is the right angle. Typically, there'll be a right angle symbol there to begin with. But if I want to find C, I can use, once again, obviously, the Pythagorean Theorem. This is going to be a little bit, this is going to be fewer steps than the last one. And I'll show you what I mean. We'll call this side A and this side B. Remember, which one, whatever side you call A and B is not important, right? So this side here, 13, could be B. This side could be A, and it wouldn't matter. Alright, so let's plug everything in. 13 squared plus 6 squared equals C squared, right? That's A squared plus B squared equals C squared. And 13 squared is 169 plus 36 equals C squared. Okay. 169 plus 36, plug that into your calculator, get 205. Okay, so C squared equals 205. We square root both sides, and we get that the square root of 205 is probably, yeah, it's a messy number. It's going to be 14.3-ish. For right now, you can leave that as a decimal form, and I'm not particularly concerned about it. So we got about 14.3 for C. You can always check your answers for kind of, you know, at least are they realistic or not. The hypotenuse should always be longer than the other two legs, and we check it out, and it is in fact 14.3 is greater than 13 is greater than 6, so it works. So, okay, let's move on to Pythagorean triples. When we talk about Pythagorean triples, what we're talking about are special basically side lengths of right triangles, and I'll show you what I mean. If I say it's a 3, 4, 5 triangle, that means that I've got a triangle, right triangle. Oh, that's not very good. I've got a right triangle, and the side lengths are 3, 4, and 5. You can probably guess which side is the hypotenuse. It's going to be the longest side, obviously, so that would be 5 units. Could be 5 inches, could be 5 centimeters, whatever it is. This would be a 3, 4, 5 triangle. Okay, so let's check and make sure that this actually does work and verify that the 3, 4, 5 is an actual right triangle. It's possible to build a triangle like this. And so let's put in into the Pythagorean theorem 3 squared. Oh, hey. It's a big font. Alright, we'll put in 3 squared plus 4 squared plus 4 squared, and see if that equals 5 squared. And I think you find out that 9 plus 16 is 25, which equals 25. The cool thing about this, that we can, if we think back to similar triangles, that any multiple of 3, 4, and 5 will also be a right triangle that comes out nicely or perfectly or even. So for instance, if we multiplied all these numbers, 3, 4, and 5, if we multiplied them all by 2, 2 times 3 is 6, 4 times 2 is 8, and 5 times 2 is 10. 6, 8, 10, that would be a triangle that would work. We could multiply them all by even 3. 3 times 3 is 9, 4 times 3 is 12, and 15. That would be a triangle. So any multiple, or maybe even we could think of it as a scale factor of this 3, 4, 5, will give us another triangle that works out perfectly, or the side lengths work out to be whole numbers, work out nicely. Let's try multiplying by 6 and see what happens. So if we take 3 times 6, that's going to give us 3 times 6 is 18, 4 times 6 is 24, and 5 times 6 is 30. So that looks pretty familiar. If I think back to the triangle up here that we had, remember we got 18, 24, and 30. If I think back to the triangle over here in the upper right hand corner, I think that's what we had over here too. We had 18, we had, better put this in here, this was 24, right? We found that out over here, that's 24, and then 30, 18, 24, 30. So that's why that one worked out nicely. And so let's slide back over here. In fact, we could generalize this into not just, multiplying by 2 or 3 or 4. We could just say, hey, if we take 3 times any number x, 4 times that same number x, and 5 times x, anything that fits that category, 15, 15, 20, 25, whatever it is, anything that fits into that category will work. And where, in this case, x is we would call it our scale factor. Okay, and it turns out that this is true for all of our Pythagorean triples. So it works for 5x, 12x, and 13x. These are the other Pythagorean triple families over here on the right. It works for 8x, 15x, and 17x. And it also works for 7x, 24x, and 25x. Remember, too, that x is just some number that we pick 8 times, maybe 5 times 2, 12 times 2, 13 times 2, as long as we're multiplying all by the same number. Okay, let's move over to the other side, over to the right here, and look at how we can use these. In this example, I want to find the third length of the triangle. This is the leg, or the hypotenuse. Okay, so I'm giving you 2 lengths of the triangle. Alright, and I want to find out what the third one is. Okay, so I could have a triangle, some sort of right triangle. I don't know what the lengths are. I know 2 of them. But the other thing I don't know is that which one, if any of them, are the hypotenuse or not. Now, I know the lowest number. That must be one of the legs. But 26, I don't know if it's a hypotenuse or a leg. And that's my second question I want to find out. The way I go about this is that very first thing is I want you to do is find a common factor between both numbers and kind of take that factor out. So the first thing I'm going to do is find a common factor. Okay, so that's a number that goes into both 10 and 26. I'm going to pick 2. So I'm going to take 10 divided by 2. It's going to give me 5. 26 divided by 2. That's going to give me 13. So what I'm trying to determine here is what have we know it's a triple. What factor have we used to kind of scale up one of these families of triples over here on the left? Okay, so let's find out. When I do that, divide by 2, I get the numbers 5 and 13. So I go over here to my families and I check. Hey, it looks like I've got a 5 and a 13. Must be that missing number is 12. So it must be the case that 12, well, let's go orange, 12 is my missing number. Is it a hypotenuse or a leg? Well, it's not the biggest number, so it must be a leg, and that's how we're going to use these Pythagorean triples. You probably noticed we're missing one thing over here that I do need to know is 12 is my factor. That's kind of this is the base family, 5, 12, 13. But I multiplied everything by 2, so I better multiply 12 by 2 to give me that third side. So let's go ahead and put in what we know over here. We know that 26, that must be the hypotenuse because it comes from 13, so 26 is the hypotenuse. And then 12, well, we multiplied by 2, we divided by 2 to get to 5, we divided by 2 to get to 13. If we want to go back up the other way, then we need to multiply by 2, sorry, it's kind of sloppy, to get to 24. 12 times 2 is 24, so this third side is 24. 10, 24, 26. And if we took a 2 out of all those, we would see that it fits right in with this 5x, 12x, 13x family. Okay, I want to come over here and I want to try the 30, 50. I want you to try that one on your own. And then I want to try this 41, or 45 and 51 problem here. With you. So, once again, the first thing I do is find some sort of factor that goes into both 45 and 51. I think they're both divisible by 3. Right now I'm trying to find out what family these numbers come from. So 45 divided by 3 is 15. And 51 divided by 3, that is going to be 17. 15 and 17. So the next thing I do is I come up and I check. Do I have one with a 15 and a 17 in it? Looks like I do. 8, 15, and 17. So if I know that it's from that family, then I must know that I've got 8, 15, and 17, that 8 must be somehow worked into that. Okay, and this is another way you can look at it. 8 must equal some number divided by 3. I don't know what that number is, but it's my third side. In fact, I know it's my shortest side, but it's some number, and I want to figure out what that number is. Let's call it maybe A, because I know it's a leg. To find that number, I'm going to multiply both sides by 3, okay, and that's going to give me A equals 24. Okay, so the 3 sides to my triangle then are going to be, here's my right triangle, one of them is going to be 24, my shortest side. Another one is going to be 45, right, that's my leg, and then the longest side is 51. So my triple in this case, if I wanted to kind of write it out in official order here, 24, 45, 51. This would be the side lengths to my triangle there in green. So this is just another way you can look at it, another way to do it if you want to think about it a little bit more algebraically. This is what's actually happening when you find that third side, what it actually is. So first find the family it came from, and then figure out what that side length actually is. Okay, last and real quick here, I want to do the area of an isosceles triangle. I try to keep these videos as short and brief as possible, and try to get as much content in as possible at the same time. So this one's running a little bit longer than I hope, but let's get started here. I want to find the area of this triangle. Okay, well I know the area of a triangle is A equals 1/2 the base times the height. Remember that this is the height, right? This comes down and it forms a right angle. That's my height. And then this right here is my base. This bottom line here is my base. Well, in this one example, my base is 10, right? 5 plus 5 is 10. In my height, that's a question mark. I don't know what that is. But I can find it because I know the Pythagorean Theorem. Okay, so I know that I've got a, if I look at this, let's look at this triangle on the right here. I've got one leg is h, another leg is 5, and the hypotenuse there is 13. So I can use the Pythagorean Theorem to find this, right? H squared plus 5 squared equals 13 squared, right? And I can find h. But let's look real quick. I think that 5 and 13 are part of one of my families up here. Yep, it looks like 5, 12, 13. That's one of my triple families. So the missing length, h, must be 12, right? So I can do all the algebra, or I can just get down to h equals 12. Once I've found h, no longer is it a question mark, it equals 12. Then I can find the area of this triangle. So the area of the triangle, A, equals 1/2 times the base times the height. So 1/2 of 10 times 12. And you get down to A equals 1/2 of 10 is 5, or so you get down to A equals 60 square meters. I'd like you to try that last example over here by yourself. It might not end up being a triple. I'll give you a hint real quick. You are looking for h again, and now I know the base of the whole thing is 30, but that this short length here must be 15, or half of 30, and that this is a right angle. So that's kind of your start to this problem, but do that one on your own. And then that completes section 7.1. Like I said, this ran a little bit longer than I like them to go. I try to keep them shorter than this, but it is what it is. So good luck on your 7.1 homework.